Hi there, Marco here from Kitanda. So we finally reached the end of Spring 20. There was a lot of work done on Dogen on Spring 20, and we're quite happy with it now. Where it's very much on feature parity now, feature complete, should I say. In other words, it's more or less providing all the features we require for the development of other products. There's still a lot of things we can do with Dogen, of course, but and there's a lot of things still in the backlog with our stories. But the point is, it now supports most of the scenarios and most of the stories that we require for product development. So we're going to slow down a little bit in the development of Dogen, but it's pretty packed for this iteration. So we now have STL and Boost support. This means you can now use STL types and Boost types. These are only select few types, but they are all the types that we think we're going to need for the foreseeable future. As we need more types, we'll add them. We also support inheritance and composition. We only support single inheritance by design, but you can do whatever you want in terms of composition. You can now mix and match your handcrafted codes with code that was generated by Dogen without any problems, and you can generate exception and enumeration classes from within Dogen. We also improved the handling of keys, which was a bit cumbersome in the past. It was not very type safe really, but now it's a bit better. And now you can generate models that actually make use of other models. Okay, so without further ado, we'll start with the STL and Boost models. So I just created a couple of diagrams here, my model and other model. They're very simple. I'll cover the model in a second. My model just contains a class and it contains nothing on it. I've got a recent build of Dogen just lying around here, and I've got a project demo 20 with basically the models that I spoke about already co-generated, and a very simple driver. I've also created a few aliases such as EM for Emacs, DG for Dogen, and what DG does is runs against my model, verbose, deletes any extra files. It will put all the files into the namespace demo 20, and the rest of the options I'll cover in a minute when we get there. I also have an alias MK that just goes and does a make, and will also prettify the output formatted for us. So if I just do a DG and MK, it's going to go away and build the current state of the model and give it the JSON outputs of the type. So you can see nothing to show. What I'll show you as well is I'll just show you the contents of our driver. It's very simple. It has our type and support for AO, and it contains our test data generator. Just creates an instance randomly populated, well, not quite randomly, but automatically populated instance of our type, and just dumps it to a string. So very straightforward. So now in the past, of course, you could do very simple things such as create a property, say prop0 of any primitive type, so say unsigned int, save that, and then do our DG and MK. And of course, Dogen would happily take that and generate a class with a property of type int. That was not still available, and it's not a problem to do that. But now you can do more interesting things such as perhaps use a std string. You just pass it as you would with a primitive. But now the advantage is, or the feature is, that Dogen will go away and do all the serialization, hashing, and so on work required for this, and we'll also create a nice little test data for it. And this is not limited to simple mere strings. You can also use containers. So, for example, if I just do a std vector, it will go away and populate and create a std vector, a class containing a std vector, and helpfully our test data generator generates 10 instances, so you can see how it looks like. You can also use things like maps and so on, and it will just work. So what I'll do now is I'll demonstrate the Boost model. So I'll just create something here called, I don't know, header maybe, and just for a laugh we'll just give it a property of type int. And what we'll do is we'll just create prop 4 or 3 if I could count of type Boost shared pointer of other. And as you can see, so now what we expect Dogen to do is to go away and treat this as a pointer, and to generate all the shared pointers and so on, and to also give us some test data for it. So as you can see here, prop3 is now a pointer, type shared pointer, and there it is. Prop3 was helpfully initialized to 3. So this demonstrates the use of STL types and of Boost shared pointers. Let's go over to inheritance and composition. I mean, you've already seen a little bit of composition because, of course, other is being used from within my class. You're free to use the association and any relationships basically in UML. Dogen doesn't actually make use of it because there's not enough information here for it to determine what you want to do with it, but you can use it for your own purposes to just make things clearer. You're also free to just do any composition you'd like. So for example, if I have a prop 4 of type other rather than a share pointer, we'll just go away and give it another other. Okay, there's our second other. In terms of inheritance, you can create, say, a base class. Let's just give it a nice little property of, say, int, and you can inherit from this class. In this instance, we actually care about the inheritance, UML inheritance, because we use it to determine the presence of inheritance. And you can have properties on this type as well if you wish. We'll just give it a int as well, make life easier. And so it shows in our JSON. I'm just going to create a property here of type derived. And that should do it. So what this should do now is to generate base and derived, all the infrastructure that goes with it, of course, serialization. It also will generate the property now created inside of the my class, and it will dump it to the okay. You can see here, type is derived, parent is base. So that's all well and good. So you can now do this sort of inheritance and composition relationships. You can also mix and match handcrafted codes with code that was generated by Dogen. So the way we're going to test this is I'm going to grab our, you can see here I'm grabbing the log for housekeeper. That at the moment is telling me that oh, okay, it seems that we already have a my file here. What I'll do is I'm just going to ls this file so you can see what the file is. My model includes demo. Okay, so I have a my file here, and that file is being ignored. What I'll do is to show the differences, I'll just create another file here called other.hvp. Now if we just run Dogen again, and if we grab the log, you can see what's happening here. Basically, as I said in the beginning, we have a couple of options here I didn't explain. One of those is ignore files matching regex, and we're ignoring the regex of my file. Now, because my file.hpp matches that regular expression, we are ignoring this file, and we're not actually deleting it. However, the file I just created, other, it does not match the regular expression, so therefore we're actually removing it. This allows you to put any regular expression you wish, or any combination of regular expressions. You can put multiple of them, and just ignore any files you wish. So this is actually a very useful feature. We also improved the handling of keys. Now in the past you were able to, all types made use of a key, which was common to all types, and it made it quite complicated, quite type unsafe to determine what key belongs to what type. So what we've done now is we changed that slightly so that the keys are generated on demand, and the way you do that is by using our new stereotype. So if you mark a type as keyed, Dogen will go away. Let's just go back to our Dogen, okay. Stereotype just changed recently, it could be versioned. Or keyable even, sorry. Okay, perhaps it's versioned. Sorry about this. Ah, yes, versioned. Apologies for that. So basically, this type version actually triggers Dogen to go away and create all support for keys for this particular type. And what that does is effectively creates the version and the version keys of the type, and we'll also add the necessary getters and setters to the type in order to provide support for the key. So what you can see now here is version key is now available on this type, and it tells you the ID and the version. And that's all part of the type, my class. So that's a very useful feature. You're also able to generate exception classes. So what I'll do is I'll just create a couple of things here, maybe an enumeration and an exception. So I'll just create my exception. I'll just call that exception instead of the type, and move it over here to the side, and I'll just do the same thing for enumeration. Diagram is getting a bit crowded. My enum of type enumeration. In this particular case, you have to actually give it values. So, for example, I'll just call it some val, and that is enough. So I'll just move this a little bit to the side so we can see all the types at the same time. Now, if I just go away and do a DG and MK, what we should see here now is Dogen should now go away and create two new files. The first one will be for the enumeration, the second one will be for the exception. These are handled correctly as C++ exceptions and enumerations. On the exception case, you get all the support for the exception integrated with it, so you don't have to do anything special. You can just start using your exception straight away, and it will work. So our JSON is not going to show as much, but what I'll do is I'll quickly hop on and show you not quite my file, but my model. And in the domain, you can see all the files we're generating, and the exception is here. As you can see, it's all boost exception and std exception, and it follows all the patterns for exception. It's all very nice. And the enumeration is created here. All enumerations use unsigned in for the moment. We haven't needed. We also add automatically invalid as 0 to make sure that that type is reserved. This is a good practice. And then there's the value that you've created. So that's all very well and good. Now, finally, we're going to talk a little bit about models that depend on other models. This is also a very useful feature. So as you saw in the beginning, I had created another model called other model, surprisingly. What you can do is you can very simply go to your attributes and add, say, property of 6, and let's just call this other model, and your class. Now your class is the name of the class, it's the other model, of course. Let's just double check that to make sure we don't make a mistake. Your class, correct. So other model, your class, and now all we have to do is, I'm just going to show you the command line for Dogen again. All you have to do is make sure that you reference the other model so that Dogen can include those types. Once you've done that, everything is ready to rock and roll. So now what's going to happen is, I'm just going to run Dogen again, and it's going to go away and it's going to regenerate all the types. Will take a few seconds. And as you can see, what's happening now is that it's generated all the types. So what we'll see here is prop 6 of type other model your class has been generated, and it belongs to a different model, of course. So you can see there it referenced the int. What I'll do is I'll just quickly, just to show you what's going on, I'm just going to open up my model, includes demo. Let's again open up the wrong file, no problem. We'll just go back to my model, and in my model we can see that my class now correctly includes all the files you can see there at the model, files that belong to a different model. So that looks correct. And that's everything we got for today, actually. As you can see, there's a lot of features that have been added to Dogen. A lot of work that was carried out in this iteration, and we're quite satisfied with its current state. So I hope you enjoy it. Bye for now.